Welcome to Head or Tail Education. Today our topic is motion on an inclined plane. So to understand motion on inclined plane, first we need to know few things. So this is the first is moment of inertia, I. So definition is the moment of inertia is an object's resistance to angular acceleration. If any particle in the rotational motion, then its the moment of inertia value is the mass of particle and the square from the distance of rotation axis is equal of the multiply. Okay, so according to this diagram or picture, we have the rigid body, and in this rigid body we have small particles, means different particles, because the rigid body is collection of the particles. Okay, and all particles have the different distance from the axis. So and different weights or mass are available. Suppose this particle is weight is mass is m1 and distance from axis is r1. This is r2 and mass is m2, and this is r3, mass is m3, and this is r4 and mass is m4. So all have different distance and different mass. So it means the moment of inertia equals to I equals to m is multiplied by r square. So m the mass of particle and r is equal to distance of the particle from axis. Okay, so calculate the rigid body value inertia. So because we have lot of different particles, okay, and different mass of particle. So we write this I equals to I1 plus I2 plus I3 so on In. Now replace the value of I, m1 r1 square plus m2 r2 square plus m3 r3 square so on mn rn square. Okay, so this is the sum of all particles and distance is multiplied square from axis. Now we can write like this: summation of I equals to 1 to n mi ri square, which is equal to summation of I equals to 1 to n of I. Okay, capital I. So if the distribution of mass equal in rigid body, then the value of moment of inertia is I equals to integration di, which is equals to r square dm. Here dm is a very minor or small mass of particle, which is distance from axis of r. Okay, so if all particles have same mass, so we can calculate directly by using the integration I equals to integration di equals to integration r square dm. Moment of inertia value is depends on few things: on object mass, on position of rotation axis, and on distribution of mass of object. Moment of inertia value is need not depend on angular velocity, angular acceleration, and torque. The unit is kilogram meter square, and dimension is mass of power 1, length of power 2, and time of power 0, and this is a scalar quantity. Next is radius of gyration, represented by k. Definition is the distance from the axis of rotation to a point where the entire mass of object would need to be concentrated to have the same moment of inertia as the object actual mass distribution. So means the K is the center of from rotation axis, and here is the mass. Mass is total rigid body of mass, okay, and is which is equals to I is equals to summation of I equals to n mi ri square equals to mk square. The definition is, say, I equals to mk square, m the mass of rigid body and the k radius of gyration. So if we calculate the individual moment of inertia of each particle, and which is equals to by calculating the center of k using the radius, center radius, the total mass of inertia is equal to mk square. So k equals to square root summation I equals to 1 to n mi ri square divided by m, okay. So k equals to I by m of square root. So k equals to square root of m1 r1 square plus m2 r2 square plus m3 r3 square so on mn rn square, and divide by m1 plus m2 plus m3 so on mn. So this is the radius of gyration. Radius of gyration value is depends on distribution of mass and position of rotation axis. Radius of gyration value is not depends on mass of object. The unit is meter and the dimension is m of power 0, l of power 1 and t of power 0. Next is torque. So what is torque? It is a rotational force that causes an object to rotate around an axis. So here we have a screw and this is the screwdriver. If we want to open the screw, we need to rotate anti-clockwise to open, okay. So this time the R represented by the screwdriver this direction. This is the length of R, this is R, and the force is clockwise, which is equals to this direction. So both the angle is 90 degree or maybe the below 90 degree, okay, but in our case this angle is 90 degree to open the screw, and the torque direction is this. So means the torque equals to force. This is force is multiplied perpendicular distance from force to axis. So this is the distance, perpendicular distance from force to axis. So we can write like here, torque equal to F cross R, which is equal to F R sin theta or RF sin theta. Theta is the angle between R and F. If theta equals to 0, then R is parallel to F, means torque equals to 0 here because sin 0 equals to 0. If theta equals to 90 degree, then R is perpendicular F, then torque equals to max because sin 90 equals to 1, okay. So it is a vector quantity. So in this picture diagram we saw the force is applied this direction and the R is the perpendicular of F and torque direction is this to open the screw. If we tighten the screw, the force direction is this and the angle of R is 90 degree and torque direction is same. So this is the tighten the screw. This is to tighten the screw clockwise. Okay. The right hand rule says that the thumb points into the direction of torque when the finger curls in the direction of cross product. So thumb rule is saying here torque is applied upper side and the curl finger is the product of cross product showing, which is force and R distance. The unit is Newton meter and the dimension is m of power 1, L of power 2 and T of power minus 2. Relation between moment of inertia and torque is torque equals to I into alpha. Here or where alpha is angular acceleration. Next is angular momentum represented by L or J. Angular momentum is defined the product of object, moment of inertia and its angular velocity omega. Okay. So it means the J equals to or R multiplied by P equals to M R into V. Okay. So replace the P equal to MV. Okay. Now here MR is multiplied by omega R because the velocity equals to V equals to omega R root and equals to RP sin theta, which is equal to J equals to MVR sin theta, where theta between angle of R and V. So this is the angle. Angular momentum for any rigid body or any particle system. So which is equal to J equals to J1 plus J2 plus J3 so on Jn equals to replace value R1 P1 plus R2 P2 plus R3 P3 plus so on Rn Pn equal to summation of I equals to 1 to n J of I equals to summation of I equals to 1 to n Ri is multiplied by Pi. Okay. So here this is the path of particle and this is the mass and this is the velocity and this is distance from axis R and the angular momentum direction is upside according to thumb rule. So if theta equals to 0 then J equals to 0 means minimum value, and if theta equals to 90 degree then J equals to RP equals to MVR. This is the maximum value. Now we know that V equals to omega R, so J equals to mr square. Omega. Now torque equals to dj by dt means rate of change in angular momentum is equal to torque. Unit is kilogram meter square radian per second and dimension is mass of power 1, L of power 2 and T of power minus 1, and this is the scalar quantity. Next is kinetic energy of rotation ER. So if rotate any object, that generate the kinetic energy. So definition is due to rotation motion produce the kinetic energy is called kinetic energy of rotation, means ER equals to half I omega square again equals to MRV equals to MR cross omega R equals to RP sin theta. ER equals to J square by 2I because J equals to I omega. ER equals to half J omega. Next, okay. ER equals to half mk square omega square because I equals to mk square. Next is rotation power, PR equals to omega is multiplied by torque. Change in rotation motion energy equals to work did in rotation motion. Next, if object rotation motion along with linear motion, then total energy value is equals to, means if the object have both motion, rotation and linear, then total energy is equals to E total, means energy total equals to energy rotational plus energy linear, means the half I omega square plus half mv square. Okay, now replace I value equal to mk square, so half mk square, and omega square is v by r square, okay, plus half mv square, which is equals to common half mv square and 1 plus k square by r square, and where m is the mass of object. Unit is joule or arc. Dimension is mass of power 1, L of power 2 and T of power minus 2, and this is the scalar quantity. Next, motion on an inclined plane. Okay, so this is our inclined plane. This is the height of inclined plane, and this is the base, and this is the distance of inclined plane from A to B, and the object is here on top of this, and acceleration is bottom g, okay, and the angle is theta from base. So if length of inclined plane is d and the angle from base is theta, okay, the first point is, if the object slips only, then motion is positional only. Okay, so means the object is slip only, like this. So this motion is positional, means A to B or B to A, like this. So position is changed. So in this state, what happened? The decrement of potential energy, which is equal to increment of kinetic energy, means the potential energy mgh equals to kinetic energy half mv square. So both are equal. So here if we remove the mass, okay, so this is remove the mass, so again comes value equals to v square equals to 2gh. Now this is the point A. Now this point is velocity equals to, velocity of point A equals to 2gh of square root, okay, because this is only, so v equals to 2gh of square root. Now next, what is the height of h? So height of h is equals to d, and this is the angle of sine theta. So h equals to d is multiplied by sine theta. This is the height of h. So we can replace equals to the velocity of point A equals to 2g d sine theta. So h is replaced by d sine theta. So velocity is equal to point of A equals to square root of 2g d sine theta. Now next to the acceleration. What is the acceleration is produced in the object? So acceleration produced in object, which is equal to g sine theta, because gravitational acceleration, okay, also work here. So this is multiplied by g is multiplied by sine theta. Next point is, if the object topples only, then motion is positional and rotational. Means object is moving from rotate and come down like this. Okay, so this type of motion is positional and rotational. So we know that mgh equals to half I omega square plus half mv square, means the potential energy equals to half I omega square, which is kinetic energy of rotation, and plus half mv square, kinetic energy of linear. So after adding, so we know that I equal to mk square, so replace this value, so we got equals to half mv square is multiplied by 1 plus k square by r square, where m mass of object, v velocity, k radius of gyration, and r equals to radius of object. Now calculate the velocity of object. So v equals to square root of 2g d sine theta divided by 1 plus k square by r square, which is equals to square root of 2gh divided by 1 plus k square by r square. Now next, in the same topic, motion on an inclined plane, calculate the acceleration. Okay, so acceleration produced in object along with plane. Okay, so how to calculate? By using the third rule of velocity, which is equal to v square equal to u square plus 2s. Here our initial velocity u equals to 0 because the object on top of in stable condition that time. Okay, so u is equal to 0, and the distance from climb top to bottom s equals to d. So v square equals to 2ad. Okay, now a equals to v square divide 2d. Next we put the value of v. Okay, so after putting the value of v, so value of v is this. Okay, and we replace the value of v, so a equals to 2d g sine theta upon 1 plus k square by r square is multiplied by 1 upon 2d. Okay, so 2d and 2d is removed from here like this. So after we have the g sine theta divided by 1 plus k square by r square, this is the acceleration, and also we can write like g h divided by d is multiply 1 plus k square by r square, because we know the height equals to d sine theta, so sine theta is replaced by h by d here. Next, duration of object topples on client plane. So what is the duration from top to bottom objects? Okay, well, so we calculate this by using the second rule of velocity, which is s equals to ut plus half at square. Here initial velocity u equals to 0 because we know the object in top of the plane, object on top, and distance top to bottom is s equals to d. So u is 0 means this value is 0. So after that d equals to half at square we have the. Okay, so time is equal to t equals to square root of 2d by a. Now a we already calculated, so this value we can replace directly here like this. So we can replace also like this. Okay, so this value, so t equals to 2d, this is also, and a equals to this value. Okay, so t equals to square root of 2d is multiply 1 plus k square by r square divided by g sine theta. Okay, so this is the duration of this. Now next, some points. the shape of different types of objects, the value of k square by r square is different. Okay. Next, the value of k square by r square is low, then object will reach first to bottom plane. Okay. And the value of k square by r square for some object is like a ring equals to 1, disk equals to 0.5, cylinder is also equals to 0.5, sphere cell equals to 0.67, and solid sphere equals to 0.4. Now last, this is the comparison between the linear motion and rotation motion. In linear motion side, initial mass, rotation motion side, moment of inertia. The displacement is here s. Here is displacement, angular displacement theta. The linear velocity here v, this is which is equal to ds by dt. The angular velocity here omega equals to d theta by dt. Linear acceleration here a equals to dv by dt or d square s by dt. In same, the rotation motion, the angular acceleration is alpha equals to d omega by dt equals to d square theta by dt square. In linear side, the linear momentum p equals to mv, and rotation side, the angular momentum equals to L equals to I omega. Linear side, force equals to F equals to ma, which is equals to m dv by dt, again is equal to dp by dt. Okay. Now torque is here same, so torque equals to I alpha equals to I d omega by dt and equals to dl by dt. Impulse j in linear side, j equals to f is multiplied by duration of time delta t. Also same, impulse j is here, the torque is multiplied by duration of time delta t. Now linear motion kinetic energy equals to half mv square. Now rotational kinetic energy er equals to half I omega square. Work in linear motion is w equals to force into distance, means force fs. Here work is torque into theta. Okay. The power in linear motion is p equals to dw by dt equals to force into s divided dt equals to f into v. Okay. Here power is torque is multiplied by omega. Okay. Means angular velocity. Relation in linear side, relation between momentum and kinetic energy, p equals to square root of 2me. And in rotational motion, relation between the angular moment L and rotation kinetic energy er is L equals to square root of 2I er. Okay. Now in linear motion, the equations of velocity is equal to, the first is v equal to u plus at, the second is s equal to ut plus half at square, and third is v square equal to u square plus 2s. So v is final velocity, u is initial velocity, a is equals to acceleration, and t is equals to time, and s is equal to distance. The same like in rotation motion, the equation of angular velocities, so omega equal to omega 0 plus alpha t, theta equal to omega 0 t plus half alpha t square, and third is omega square equal to omega 0 square plus twice alpha s. Omega is final velocity, omega 0 is initial velocity, alpha is angular acceleration, and t is time, and theta is distance for rotation motion. Now tell summary. So we learned in this tutorial moment of inertia, radius of gyration, torque, angular momentum, kinetic energy of rotation, rotation power, and how to calculate of all. Next, we discussed about the motion on an inclined plane and calculate the velocity, acceleration and time of object. Okay. Last we saw the difference of linear motion and rotation motion in physics. Hope tutorial is very helpful to understand the motion on an inclined plane in physics. Thanks to watch Head or Tail Education.